Okay, let's spend a few minutes talking about circle area and circle circumference. Area, of course, is like any other area, and circumference is like perimeter. It's the distance around a circle. So to do that, we're going to need to talk first about pi, and then we're going to talk about circumference as a formula and area as a formula. So first, let's talk about this thing pi. Now, I've drawn two diagrams here. One represents a blueberry, or the picture of a blueberry from a distance. That's a circle. And the other one is the moon, the Earth's moon. And you can see that both are circles. And if we were to measure the blueberry, it has a circumference, so a distance around the circle here, of 3.77 centimeters. And it has a diameter, so that's the distance across the circle through the center of the circle, of 1.2 centimeters. Okay? Now let's look at the moon. The moon has a circumference of approximately 6,783 miles and a diameter of approximately 2,159 miles. Okay, you might say, okay, why are you giving me all these numbers? Well, the interesting thing is if we divide the circumference by the diameter of the blueberry, if we take 3.77 divided by 1.2, we get 3.14. There's a few continuations of the decimal. I'm rounding to the hundredths place here, 3.14. That's for the blueberry. Now, if you think about the moon, you take 6,783 and divide it by 2,159, the same calculation of circumference divided by diameter, and guess what you get? 3.14. That's really cool. So anywhere where you find a circle, the ratio of the circumference to the diameter is always the same number. And that's roughly 3.14. And so let's go ahead and write that as a rule. The ratio of a circle's circumference to its diameter is always the same number, regardless of the size of the circle, whether it's blueberry-sized or moon-sized. And a few more things about this. Pi, the Greek letter pi that we write, it's kind of like a T with an extra little stalk going down. That represents that number, that ratio of the circumference to the diameter. It's approximately equal to 3.14, but it's a decimal that never ends and never repeats. So it's 3.14159, blah, 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 blah. They've taken it out to, I think, hundreds of thousands of decimal places. It never repeats. And what we discovered this as human beings thousands of years ago, that there was this idea of pi, this constant ratio between the circumference and the diameter of every single circle. Okay, so that's an important thing because that's going to be the basis of both the circumference formula and the area formula. Let's first look at the circumference. So here we have, if we are given the diameter of a circle and we want to find the circumference, well, we know that C over D equals pi, always. That's what we discovered here with the blueberry and the moon and our rule. So if C over D equals pi, you can multiply both sides by D to get C by itself, because that's what we want to find. And the D's will cancel out on the left-hand side or divide to be 1. And on the right-hand side, you'll just have pi times D. So then our circumference formula becomes C equals pi D. So anytime you're given the diameter of a circle, you can find its circumference just by multiplying it by pi. Now, a lot of times you're not given the diameter, you're given the radius. So that's just half of a diameter, obviously. It's the distance from the center of the circle out to the edge of the circle. And so how do you find the circumference given the radius? Well, you can start with the same formula that we have above, C equals pi D. But D is just 2 radiuses, or 2 radii, right? So we can put 2r in for D. And then we can rearrange things a little bit there, and we can have C equals 2 times pi times r. Do you see how we get this formula right here from this by just rearranging a little bit? And that is the circumference formula when you're given the radius. And that's the one you'll probably be using the most. So let's do a couple of examples using this formula. Find the circumference of a circle with radius 5 meters. Okay, so we can set up our equation here, C equals 2 pi r. And what would you do? Yeah, you'd put the 5 in for the r there. So we're going to go ahead and write that as 2 pi times 5. And then what's 5 times 2? Right, it's 10. And we can keep our answer in terms of pi a lot of times, unless we're asked to do differently. So the radius of a circle, the circumference of a circle with radius 5 meters is 10 pi meters. Okay, now let's do another example, or let's continue this example and say, use 3.14 for pi to calculate a decimal answer. So we're going to keep this same example here, but instead of putting it in terms of pi, we're going to put 3.14 in for pi. So let's go ahead and do that. C equals 10 times, instead of pi, like we have here, we're going to put in 3.14. We just multiply that. You know, when you multiply by 10, you move the decimal place 1 to the right. So the answer is 31.4 meters. And that's the circumference of a circle with a radius of 5 meters. Now, with the area formula, we're not going to go ahead and prove it right here, kind of like we proved the circumference formula from our ratio of pi. But there is a proof for it. You could handle it. You could understand the proof for it, but we just don't have time to go into it now. But basically, we have known as human beings since ancient times that there's also a formula for the area of a circle, and we can calculate it by multiplying pi times the square of the radius. So when we're given r here, we can multiply pi times r squared, and that will be the area of the circle. And so let's do an example here. Find the area of a circle with radius 9 centimeters. Okay, so what are we going to do with that 9 centimeters? Right, we're going to put it into our formula, just like that. And then what's 9 squared? 9 times 9? Right, it's 81. So the area of that circle is 81 pi centimeters squared. And if we're asked to go ahead and use 3.14 or a longer decimal like 3.14159 for pi, we can substitute that in to calculate the decimal version of the answer. You'd probably want to use a calculator for this, or you can do it by hand. But when we do that, we get 254.34, and we probably want to round that at some point. So we can say the area is equal to 254.3 centimeters squared. So these two formulas, circumference formula and area formula, they all go back to pi. And once you should probably memorize both these formulas. Circumference equals 2 pi r, and a equals pi r squared, and then you're good to go.